Okay, let's try that. So welcome. This is Glass, Greater Lansing Area for SQL Server. Every month we try to have some topic on the anything pretty much in the Microsoft data stack. Started off SQL Server, but now Microsoft's doing a whole lot more than just that anymore. So we try and meet once a month on that. And this month we have Jess Schultz, Girl Geek on Twitter. Frequent if you are hanging around the SQL family hashtag, see her on there quite often. Just the few 10,000 of your closest friends that all love SQL Server as much as we do, and then she worked for Ozar for a while, and now she's at Microsoft, and just recently got a nice promotion to program manager, which then resulted in her calendar getting very busy, and so we shifted a few days, and so here we are on July 21st, and and I'm just gonna, I don't know if you want to give a plug for, kind of like you did for me describing your current role, because that really did sound pretty cool. And Jess, they came here to listen to you, not me. So
Okay.
turn it over.
Yeah, I am happy to start presenting and rock and roll. Let me make sure I get the right one. So yes, the topic I'm going to, nope. Are you seeing my slides?
Yes, which
Teams is giving me conflicting messages about which screen it's presenting. No surprise.
No,
okay.
This is the presentation mode looks like.
Okay.
So
excellent. So I'm here tonight to talk about which Azure SQL database options should I choose. So thanks for the great introduction, Michael. But yeah, so Jess Schultz. I just started as a program manager, but I've been in the SQL Server world and community for a long time, starting with my first SQL Server reporting services, 2005 report writing gig, all the way up to being a consultant and a Microsoft MVP, and now a field engineer and software engineer and PM at Microsoft. Here's my email address, my Twitter handle, my GitHub. I give people that instead of my blog nowadays because it's so much easier for me to do things like put slides up there, put scripts up there. So if you're ever interested in some Azure resources, look for my Azure repo out on GitHub. Plenty of things that are useful to be able to be downloaded. So yes, my role right now is, so I have joined the product group to work on Azure Arc enabled data services. So Azure Arc is Microsoft's hybrid cloud strategy. It's allowing people to take resources that are on premises or in AWS or in Google Cloud or really anywhere else you can host a virtual machine, a Kubernetes cluster, put in like an agent on there, and then it sends data back to Azure, and you can see these resources from other locations in Azure in the portal. You can manage them with all the same familiar tools. So it's kind of a put your compute where you want it and run your services in Azure. I'm focusing on running SQL managed instance, which is one of the SQL features we'll talk about, on Kubernetes clusters in Arc. So using containers, being able to pull in a platform as a service offering on-prem, have it constantly be kept up to date, have all of those features available. This is a fairly new product. The first version of it is just going from public preview to general availability next week. So it's relatively new. I've just joined the team, so you'll probably be hearing a lot more about that from me in the coming months. What I'm here to talk about tonight, again, is just the different Azure SQL database options. Azure SQL itself is now 11 years old. I want to say it debuted in 2010. So it's not a new service anymore. but it's matured significantly since it first came out. We've gone from it being just this very basic relational data store that was meant to go hand in hand with like Azure app functions. And it is now fully fledged, tons of features, tons of options. So the benefits of Azure SQL, which we'll talk about here, are, there we go. Got to get PowerPoint to play along nicely with me. Why choose Azure SQL, right? Why go into the cloud and do something other than run SQL Server on a virtual machine? One of the features is what we call cloud first or cloud native development. So most new features are released into the Azure SQL code before they get into a SQL Server release. You know, in the cloud, we ship things, you know, every month, every couple of months, whereas SQL Server releases are more often, you know, years between them. Think, you know, 2014, 2016, 2017, 2019. More rapid development allows for features to show up earlier. You know, a big one, for example, was Query Store. That was in Azure SQL well before it was available in SQL Server. So if you're interested in being able to access newer, better, faster, earlier, yeah, that's one great decision or one great reason to pick Azure SQL. But it also comes in, you know, as a platform, as a service offering in Azure, which means that there's a lot of benefits provided by the what we call the Azure Service Fabric, right? That underlying technologies. These are things that are designed to take the management and maintenance responsibilities away from the customer and let them focus on scaling out, making improvements to the code, really focusing on applications rather than things like backups, because those are performed automatically. High availability is built in, and we provide SLAs around how much uptime you'll have. Disaster recovery is very easy to set up, very easy to use. Unlike the days of, you know, physical machines where if you needed more memory, it could take weeks or months to get it installed and, you know, restart the server, or even virtual machines where you might have to, you know, wait to get another host that has enough resources and have all the virtualization stuff split up and again restart. If you need more CPU, more memory, if you need less, it's very easy and often takes seconds, maybe minutes, to just switch between them rather than days, weeks, or months that we have to wait otherwise. And another thing that I love about Azure SQL is through the portal and through some DMVs, there's also a really good set of performance improvement tools. This allows database administrators to quickly figure out where problems might lie. It's also great for companies where, you know, maybe we have a lot of developers and not so many DBAs. I'm sure all of us have been in that situation at one or more points in our careers. So they can use tools like Query Performance Insight to see, you know, top 10 CPU consuming queries, top 5 memory hogs, that sort of thing, and then get tools or suggestions on how to fix it. Things like automatic plan correction, automatic index tuning. So again, the point of Azure SQL, running this platform as a service offering in the cloud, is truly to take some of the management, maintenance, patching work that's repetitive and frequent, take that off your plate and allow you to focus more on the modernization, the performance improvements, and that sort of thing. The downside is that when you go into, say you're just like, you're reading through the documentation, you're like, I want to create an Azure SQL database. Or you go into the portal and you click on Azure SQL, you are suddenly confronted with this slate of options that can be very confusing. So PowerPoint got away from me there. I am going to be talking through the 4 main things that you need to decide between when you're setting up your Azure SQL environment, which are going to be your deployment option, which is how do I structure the server and its databases? The purchasing model, which is how am I paying for my compute and my storage? The service tier, which is, okay, once I've decided how I'm paying for it, how much do I want? And then what we call the compute tier, which is, will my services be available 24/7, or is it more of an on-demand schedule? So what I've done, this is probably the best slide I've ever made in my 12 or so years of presenting, and I am going to hold on to this for dear life. What I want to show you is that there's this umbrella of Azure SQL. And under it, we have all of these different options like SQL Server in a virtual machine, the managed instance, the single database, the elastic pool. Those are those deployment options. Under those, our purchasing models are the old being not recommended DTU, and then the newer vCore. Underneath that, you'll see we have that service or storage tier. So you'll see some words like general purpose, business critical, hyperscale. We'll talk about the differences between them. And then right now, if you're running single databases in a general purpose, you have this option to choose between provisioned and serverless. So this is kind of the map of offerings. That's a lot. How do you know which one to pick for any given application? Maybe it's a migration. Maybe it's a brand new application your developers want to build. I'm here to help you figure out, okay, I'm going to start at the top and work my way down this chart. So you'll notice that under Azure SQL, there are 3 things that are covered by the PaaS, or platform as a service offering. That's the single databases, elastic pools, and managed instances. Those are the offerings where the backups are taken care of for you, the high availability, the patching, all of that. But I still want to mention that infrastructure as a service offering, which is running SQL Server in an Azure virtual machine. This is still a fully supported option. Know that it is definitely available for you. When you choose this option, you create a virtual machine in Azure and install SQL Server on it. Some of the benefits of doing this, you're running a full version of SQL Server. So that means you can do things like install machine learning services, put a reporting services installation on there, or analysis services. Those kinds of side things or extra features aren't available as cloud options. So if you need that, particularly for legacy applications, it can be really helpful. You have lots of options. You can choose Windows or Linux. You can choose SQL 2019, 16, 12. Whatever is supported is available. If you do choose Windows as your operating system, Azure can take care of some of that maintenance work, like automatically updating the OS, automatically updating SQL Server, configuring automatic backups. Those things aren't turned on by default. You set up maintenance windows and turn it on if you want to, but it is available. The main reasons that people choose to use SQL Server in a virtual machine. Number one, it's a really good way to do a lift and shift. Maybe you have a company mandate that we need to move out of this data center and we need to move into a cloud provider. You probably won't have time to rewrite your applications, test all your databases in a completely different service, make sure all your connection strings get updated. Maybe you just have an older application that's running on a hardware that's not going to be supported, and you don't want to worry about having to replace the hardware in another 3 to 5 years. Consider a virtual machine in the cloud where all of that is taken care of for you. The other thing that I mentioned is just using some SQL Server features that don't have direct cloud counterparts. Do you have time to take all of your integration service packages and move them to Azure Data Factory? Do you have time to take all of your reporting services reports and convert them into Power BI dashboards? Do you have time to take your analysis services cubes and convert them in from, multi-dimensional to tabular, which is what Azure Analysis Services supports? Maybe, but maybe not. Again, running in a VM gives you the flexibility to do all of that. So again, I don't want you to think that SQL Server in VMs is not part of the family. It definitely is. It's a very popular option. So consider that, again, lift and shift. So somewhere between the lift and shift, running a full instance of SQL Server on a virtual machine and running just one database with all of that, with that limited feature set of single databases, is the managed instance. So a little bit of a history lesson. When Azure SQL started, it started as just one single database. That was all you could provision at a time. The databases couldn't talk to each other. And it was, again, a limited feature set because Microsoft was only allowing people to touch the database. Anything that was a server level option was just not available. And think about something like SQL Server Agent or Resource Governor. So single databases were really truly designed for brand new applications that were built in the cloud and could already conform to those standards. But then Azure became more popular. People really wanted to move existing databases from on-prem into this single database model, but had a lot of restrictions. So the middle tier, what I'll call, is kind of the in-between, is the Azure SQL managed instance. Now, what happens here is that it's a collection of system and user databases that all use the same compute power, but it has almost 100% feature parity with on-premises SQL Server. So it's a great way to take an existing server, do your backups, restore them into this managed instance, and have it available in Azure. And you get all of those platform as a service offering features like your backups are taken automatically. High availability is built in. We do the OS updates and the SQL Server updates. It's near 100% compatibility with on-prem SQL Server. I think right now the few things that are not supported are generally things that involve the database going into the file system, like database snapshots, file stream, maybe Windows authentication instead of AD authentication. So managed instance, again, this is another lift and shift option. The big difference is with virtual machines, you are still in charge of sizing it. You have to do the Windows updates, the SQL Server updates, the backups, the patching, all of that. With managed instance, that's all built into the service. Managed instance is also a good way to get into Azure and use features that aren't available in that single database model. A few of the common reasons or the common features that are available in managed instance that make people choose it over single database are being able to do cross-database queries, running SQL Server agent jobs. I can actually update this slide because change data capture is now available in single database. That's new. Resource governor, service broker, those sorts of things. So I'll pause for a minute before I get into single database. Any questions about managed instance at all? I don't see anything in the chat yet. I will say, since it's such a small group, if you have a not urgent question, just drop it in the chat. I'll check it every few minutes. If you have something where you're like, hold on, I need to know now, please just unmute yourself and ask. All right. So the next option under that PaaS umbrella is the single database. Again, this is that traditional iteration where there is a single database that has its own dedicated amount of resources. So its own CPU, memory, log throughput, storage, etc. Single databases are assigned to logical SQL servers. Now, you can have one, you can have thousands. Single databases were, again, designed for new cloud native applications. They do have a limited feature set because they are contained databases. So you're not going to have access to things like, again, cross-database queries, linked servers in all cases, SQL Server Agent, service broker, resource governor, things that are at the server level. But in many cases, for developers, single databases are a great feature for new development. You know, they tie in almost seamlessly with all sorts of other services in Azure. So you can create Azure functions that read from and write to event hubs. Azure Data Factory has, that's one of the simplest connectors. It's easy enough to build pipelines that pull data out of your SQL database and put it into an Azure Synapse SQL pool, the artist formerly known as SQL Data Warehouse. And again, as your developers are building new applications, we will, and they know what the parameters are, like what box they're living inside. Choosing a single database is a great choice for them. And all of these things that are not available natively, like SQL Server Agent is a big one that I hear a lot of resistance on still. I frequently ask people like, okay, what are your agent jobs doing? About 50% of the time it's maintenance operations. A lot of those can be done or are done automatically now. The other thing is there are business logic, things that run stored procedures, move data around. And we have tools like Azure Data Factory and Azure Automation that can do that. It is just a little more work to rewrite them, but they do exist. And Martin, I see your question covering, so will I be covering the economics of single databases compared to managed instances and which is more or less expensive? Not in this session, mostly because there are a ton of different factors that go into it. We'd need about another 2 hours to talk about it. If you do have specific questions about it, email me after the session, please. All right. So the last option then under that PaaS umbrella are elastic pools. So this is a group of, so instead of having one database that's given access to 4 CPUs with 16 gig of memory, in this case, a pool says I can create up to 50 databases that share 4 CPU and 16 gig of memory. Again, they're all put under this logical SQL server and managed together. Now, why would you want to do an elastic pool? The original pattern that it was designed for was SaaS providers, software as a service, that you had, for example, a finance package, and you did not want every customer to be sharing the same transactions table, right? So on-prem, you would shard that out. You'd have all of these, single tenant databases. That's what elastic pools were primarily designed for, and they work great for it, especially because when you have hundreds or thousands of customers, the chances that they all use the same amount of resources at the same time of day or day of the week or day of the month is pretty low. So instead of having to always pay for 2 CPU and 8 gig of RAM minimum for every single database all the time, just let them share the resources. The other benefit of elastic pools is they can communicate with each other, the databases, and it can. So there's a set of tools called the elastic tools, and it allows you to do like elastic pool queries. You can run a query against one or more databases. There's elastic pool jobs. Run a job against all of them. The downside is that, to the best of my knowledge, elastic tools is still in preview after 2.5 years. And there's never a guarantee that anything that's in public preview will go to general availability and be supported fully forever. So I just tell people, take that with a grain of salt. All right, so those again are our 4 main options. That infrastructure as a service offering of creating a SQL server and a virtual machine, and then our platform as a service offerings of managed instances, single databases, and elastic pools. One of the things that you'll know is when you move into a cloud, you have to pay for things. They don't let you get away with that, and everything costs money, and it's very obvious how much money it costs, and companies are always like, how do we make this more efficient? Definitely a change for a lot of companies over the last 10 years or so, going from that, really CapEx model with being able to, take a server's life and extend it over multiple years to a really OpEx model where now they see how much every single database costs every single month. So let's make sure that we understand how we are paying for it. There are 2 methods for paying for it. The original first and older method is DTUs, or database throughput units. The newer model is called vCores. So the big thing that I want you to take away from this slide, without reading all of the details, when you paid for DTUs, you paid for CPU, memory, throughput, and storage as one big chunk. If you had a small database, say, 25 gig, that had a lot of transactions because it's very busy, like almost like a session database, or just something that frequently had data in it and then went back out, you had to pay for that level of compute, and you were probably also paying for like 4 terabytes of storage. On the other hand, if you had a 3 terabyte database that just sat there and it only queried a couple of tables, you had to pay for that premium level of storage, even if you barely did any transactions. The vCore model came along and changed that. With the vCore model, you pay, so there's 2 fees. You pay one for the compute. So you get to choose, I want this much CPU, which gives me this much memory. And then separately, you get to say, I need this much storage and this much throughput. Decoupled it, much easier to understand, much easier to translate when moving from on-prem to the cloud, much more flexible. So within those payment options, there were different service tiers. So under DTUs, or elastic DTUs, they had 3 tiers called basic, standard, and premium. Under vCore, we break it out again under compute and storage. I'm not going to spend a lot of time talking about DTU, but the information is in my slides. You can go back and reference this if you need to. Essentially, what every tier gave you was a maximum amount of transactions that you could run, a maximum amount of data size, and a maximum number of IOPS. That same model applied if you used DTUs on an elastic pool. Maximum number of databases per pool, maximum number of transactions per pool, maximum number of transactions per database. What I would prefer to focus on is showing you what you get with vCore. So here, I want to zoom back real quick on one of my other slides. Okay, so managed instance, the only way to pay for it is vCore. Let me turn on my little laser pointer. Okay, so with managed instance, the only option you have is that vCore. In a single database, you can choose DTU or vCore still. Again, the more popular option and more flexible option is vCore. And again, with elastic pools, you can go with the older DTU model, but vCores are available and recommended. I will make a note here while I am switching slides that if you do have existing databases in the DTU model and you want to convert them to vCore, we have guidance out there in our docs on how to do that. All right, so in the vCore model, this left column in blue are your compute choices. We have different families of compute. Gen 5 is just a general purpose. The FS is a CPU optimized for really CPU heavy workloads, lots of data crunching, lots of analytics. The M series is memory optimized, maybe larger databases where you do a lot of reads, you want a bigger cache, that sort of thing. We have this new DC series. If you see that referenced, it's basically used for confidential query processing. So that's the first decision you make. And what you'll notice when you go to pick out something in the vCore model is your number of CPUs and your number of memory and amount of memory are tied together. After you decide what kind of compute you want, then you get to go over and pick what type of storage you want. For managed instances, we have two options right now, which are general purpose and business critical. For elastic pools, we have general purpose and business critical. For single databases, we offer all three of these options. What's the difference? General purpose is set up so that your compute exists over here and your data, your MDF, your LDF, sit in blob storage. So that means they're not on the same channel and it's a little bit slower. General purpose is great for production, not production environments. It's great for lower or workloads that can withstand a higher latency, just things that aren't business critical, don't need that tier 1 storage. Now, business critical is you have your compute sitting here on a node and it is locally attached SSD. So the storage itself is faster and there's less latency between the compute and the storage. Business critical is recommended for production workloads and anything that has faster I/O needs. Then the last thing is hyperscale. And hyperscale is hard for me to talk about without showing a picture, so I'll say that next. It's not just a different type of storage, right? It's not like, oh, it's all in memory or something like that. Hyperscale was designed as a distributed functions architecture. If you are at all familiar with like a Hadoop system where you have a head node and worker nodes and it pages everything out, it's sort of similar to that. If you're familiar with, again, SQL data warehouse, now known as Synapse, SQL pools, head node stuff is distributed out kind of along those lines. In hyperscale, we have, instead of having the query optimizer, the log reader, the log file, and the data file all sit on just one CPU, like one piece of hardware, everything in and out. It's now spread out so that there's a compute node, a primary compute node that actually runs SQL server.exe. So that's the server. Then separately, there's a log service that holds the transaction log and manages all the writes to it and reads from it. That log service then updates two pieces of storage. So there's page servers, which essentially hold the cache. There's multiple of those. They serve things up very quickly to the compute nodes. And then underlying everything is just Azure storage, which holds like your MDFs. By breaking these things apart, we're able to make things much faster and hold much larger databases. The primary use cases for this hyperscale tier. So again, general purpose, that blob storage backed storage is really designed for not production loads or non-critical production. Business critical, meant for production loads. And hyperscale is designed for anything that doesn't quite fit into those buckets. It can hold databases that are up to 100 terabytes in size. For reference, general purpose and business critical can handle 4 terabytes. So that's a big leap. The other thing that you can get with hyperscale is really high I/O. With general purpose and business critical, if you're at a lower tier of storage, you could be limited to like 32 megs per second or 48 megs per second for log throughput. With hyperscale, because of the way that log service runs on its own, even at the smallest 2 CPU, like 4 gig, whatever that smallest vCore is, you get 100 megs a second of throughput. And the other benefit of hyperscale, let me go back one, is if you're familiar with always on availability groups, how it has the primary and can have multiple secondaries and you can point to those for reads. It's the same thing with hyperscale. You have a primary compute and you can have between 1 and 4 secondaries that are just built in that you can direct your reads to. All right, so that is a quick walkthrough, and I do mean quick because there's a lot of options that I could go into of the blue, which is that purchase or compute model, and the green, or the service and storage tier. Any questions about those things and what's available where and what you should be using?
As far as the, kind of like the pricing model, recommendations on where to follow up, who to follow up with for deeper dives on that, is that going to be something you're talking to your account manager, I suppose, more about, or recommendations for how somebody should follow up, like, okay, I need to know more, and maybe like Martin's question of, which kind of gets into all this, what resources should we be looking to?
I will tell you that we have some reasonably reliable pricing calculators out on the Azure website, and I always tell people to start there.
Okay.
So the Azure pricing calculator, if you haven't looked at this recently, actually gives you some really good options for being able to choose see if I can bring this up. You pick your region. You pick, what type of database do I want? What sort of storage do I want? What type of backups am I going to have? Which hardware? So then you say, do I want it in multiple availability zones? And then you can enter are you using pay-as-you-go, or are you converting some of your hybrid benefits? And it will tell you, including, how much backups you have, what that cost would be per month. And I like to take and run multiple of these to start, just to compare, okay, if I have these 5 databases that all need to talk to each other and they need X amount of IOPS, is it better to go with 5 single databases in business critical or 1 managed instance with business critical? It's a good place to start to get some basic assumptions. After that, yes, if you have specific questions, need more in depth, your Microsoft account team is definitely the place to start.
Perfect. Thank you.
Yeah. And that, I have been on the engineering side for like the last 3 years. So I am not a licensing expert by a long shot. So I always tell people, like, please talk to your account execs, because I know how we pay for it, but I don't I'll be honest, I'm not great with the whole like hybrid benefit saves you this much and you should do the reserved instance and you should do this. I don't even understand how all of that works. And I will say this, before I move on, hyperscale is amazing. There are some really cool projects out there with hyperscale. If you get the chance to work with it, demo it, even just attend some technical sessions given by the team that works on it, it's really cool. It's one of the things I'm truly excited about with the SQL world these days. All right, the one other thing that I want to talk about is a new within the last year feature called the compute tier. Now, currently, again, if you follow my little map that I give you down, it would be, so it's currently available just for Azure single databases in the vCore model using general purpose storage, because this is still a preview feature. It will be expanded later, but know that right now it's just kind of limited. But it gives you the choice between, I want to know that my 4 cores and 16 gig of RAM will be available to my database 24 hours a day, 7 days a week, 365 days a year. And because of that, I want to pay for that compute every single hour. That's the provisioned tier. The other option is called serverless. Serverless, for the record, in case anyone ever asks you this, is one of my least favorite words in the technology world right now. There are still servers backing it up. I think this should be called the auto scale or auto pause tier, but marketing doesn't ask me what my naming choices are. So with serverless, when you set this up, actually the easiest way for me to show you this is to go ahead and get it set up. So let me pull up the portal. So with serverless, you're saying, my database does not always have to be available 24 hours a day, 7 days a week, 365 days a year. I know that I get more activity the first week of the month, or my database is in a factory that only runs for 8 hours a day. So the other 16 hours, it's just sitting there idle. What you can do is say, okay, so resource, single database, 8. You get to make choices about what your minimum and maximum number of CPUs that you want are. And so that in the times that it's active, it can scale up and down to meet the demand. And you can also say, okay, if I receive no application requests for this database for like an hour or 6 hours, pause it. Turn the compute off, leave the database in storage. And if that's turned off for 12 hours, if nobody queries the database, you're not paying for the compute. As soon as an application goes and makes a request to the database, the compute gets spun up again and you start paying. So you pay the compute per second, but again, in certain use cases, it can be much more efficient. So let's take a look at some of these. I'm one step ahead of myself. So some use cases for that serverless model. Again, databases active for a short period of time within a day, within a week, even within a month, but are then idle for long periods of time. It might be more beneficial and cost saving to just not have the compute running the whole time. Databases that have varying levels of activity and can benefit from auto scaling. So that's another benefit you get with serverless is you can say, I never know if I'm going to need 4 cores or 64 cores. I would like Azure to manage that. We can do that in this tier. The thing to know about this is, I know that all of you are thinking, Jess, I know that if I'm going to get that feature, I have to give something up because that's how computers work. We do more aggressive cache management, both in the plan cache and the page cache, to make this, to make the compute be able to go away quickly, to make it be able to start up quicker. So if you have a very memory sensitive or cache sensitive database application, might not be the best mode for this, but it's something you have to test. So let me zoom in. I know that we need to do that on this portal. I'm going to go. Yes.
Yeah, I want to interrupt just for a second. We had what we thought was a very good use case for this, and it turned out not to work out for us. And I just give you a little feedback. So we had an ETL process for a data warehouse. A vendor was giving us a SQL Server backup, and it was in 2019 format. We didn't have any 2019 servers, so we thought, okay, fine, we'll just, and it's one of those things where we load once a month and that's it. It's just a monthly dump. And so we wanted to use serverless to be able to just restore that backup, do the load, and then let it just sit idle and save all this money, as you discussed. But the problem was it wouldn't accept a BAK backup, and that was the only format they could produce. So, or were willing to produce, one or the other. It was a financial institution, and they're not very flexible. So it would have been perfect for us, except for the fact that it would not take a BAK restore.
So welcome to one of my biggest complaints about Azure SQL for the last 5 to 7 years. When I was an MVP and when I was a field engineer, you're not the only people that have had that problem, and the product group has not solved for that yet. I actually, let me show you something.
We currently are on your still the slide deck.
Oh.
So.
Oh, you know what? I bet I shared a specific thing rather than my whole screen. So give me a moment. But also let me, on my account. I don't want to change my password GitHub. I just want to see my repo. Okay, here we go. Okay. So again, you are not the only people that have had that trouble. And actually last year, I had a project working with a financial services company that needed to take data from multiple sources and import it into individual SQL databases. And one of the formats that they could get and not get in a different way was backup files. I had to write a custom application to convert these. So I went through about 2 or 3 months worth of writing this thing where a customer puts a backup file in an Azure file share. That kicks off a process to spin up an Azure container instance. that container instance is running SQL Server. There's a bash script that looks in that file share, grabs the backup, restores it to the database, and runs SQL package.exe to extract out the backpack. Then you have to take the backpack, put it into an Azure blob storage, and run a specific PowerShell command to import into SQL Database. Like, that's so much work. That's so much work. Why can't we just restore a backup? I sent this to the product group and said, hey, this is the kind of workarounds we're doing. It still gets traction. So I'm with you. It's a pain, and people have to write things like this, and I don't have any good answer for getting around that.
Right. I mean, we ended up just going with a managed VM and treating it like a SQL Server instance. But you know, we manually spin it up, we manually spin it down. So there's always the possibility that somebody will forget or get busy, and then all of a sudden we're charged for a whole month of activity when we
You're like,
didn't mean to do that.
Yeah. I'm gonna write that in an email tonight and send it to my send it to the contacts that I sent these things to. Like, just another story in the long list of stories I've sent you. It is a downside. I know there's reasons for it. But if you ever are interested in learning about this process, I would be happy to show it off to you. Probably overkill for what you need if you're doing it once a month. The financial institution I was working with was handling somewhere between tens and hundreds of backup files a week. So for them, it made sense to invest in that.
Yeah. Right. You're correct. It probably would have been overkill.
But yeah, I feel the pain. I have had to do all of these things. All right, so I'm going in and I'm trying to create a new SQL database. I'm just entering some basic information like resource group, that logical server name, that's database name. So here are some of, as we start setting up a database, you'll see some of these things I've been talking about. Do you want to use an elastic pool? In this case, no, I'm trying to create just a single database. This compute and storage option, you'll notice these words might look familiar now. General purpose, Gen 5, vCore. If you click configure database, this is where you're going to find all of these pricing options, compute, storage, serverless, all of that I've talked about. So what you choose here is, you know, what do you want for service tier, right? So are you going to go with DTU or are you going to go with vCore? And under vCore, do you want general purpose, business critical, or hyperscale? Then if you choose an option, so if I choose business critical, that serverless model goes away. If I choose general purpose, I can see provisioned or serverless. And I want to show the difference. So under provisioned, I get to choose my hardware configuration. Do I want the Gen 5? Do I want the compute optimized? Then, you know, here's my available sliders from 2 to 80 cores. I can go from 1 gig up to a terabyte of size. If I choose serverless, notice now that instead of just choosing cores, I get to choose the minimum number assigned and the maximum number assigned. So I can say that I want between, come on, one over. There we go, 1 core and 4 cores available at all times for this database. And then you get the option also for the auto pause. This is optional. So some people want this serverless tier just for that ability to scale up and down. Some people also want to say, okay, I've had no activity for 6 hours. At that point, pause it, get rid of the compute. We just want the data stored. The zone redundancy, without going into my full day Azure database architecture, you're going to create your database in a region, which is, in this case, East US. Because of high availability, there's going to be 3 replicas in East US. That's just the default. Those 3 could all be at the same data center in East US. They could even be on the same rack. We don't know. We have a new feature called zone redundancy, which allows a company to say yes. And when that happens, you're saying, I want my database and all of its replicas to remain in East US, but I need them distributed across racks, across data centers, so that if one thing goes down, I know it'll spin up in another. I know that it'll fail over to one of the replicas in the same region. This is primarily designed to solve the problem of data residency, right? There are people that, you know, you could, if you're not concerned about what regions your data resides in, you could set up disaster recovery, right? You could say, set a failover group, and my data will exist in East US. There's also a copy in South Central US. If something happens to East US, failover automatically. In certain states and in certain countries, they don't have that option. You know, certain countries in Europe cannot say, you know, have a copy of my data in Germany and have a copy of my data in England. So this is kind of that data residency requirement, just if you're curious. And so here it'll tell you, here it tells us, you know, I'm setting up 12 gigs, max storage. My storage cost will be $15.40. My compute cost per vCore per second is, you know, fractions of pennies. I say apply, and it's going to go ahead and create it. So those are, that's just kind of a really quick tour of where you're going to see all these terms I talked about and how you go about configuring them and where you'll see those settings in the portal. The other place that you will see, that the other resource that I can point you to, is my Azure SQL Server. So I have a repo out on GitHub called Azure SQL Server. And out here I have a lot of PowerShell scripts, including new AZ SQL Database, which shows you how to create a single database. New AZ SQL Elastic Pool for Elastic Pools. Hyperscale to show you how to specify that. AZ SQL Instance for managed instances. So if you are more of a script person, that would be how you can see where all of those options go into effect. All right. So I've covered a lot of stuff. I hope what you took away from this session is that we have a lot of different options out there, and you're going to see a lot of different terms in documentation. The important thing is to remember that single databases, elastic pools, and managed instances are all platform as a service offerings. You choose your vCore or DTU payment model. Under that, you're going to choose a compute tier and a storage tier. And we have some, you know, special edge features like hyperscale and serverless, which can satisfy certain requirements. You know, the goal of platform as a service, or PaaS, is to minimize your management responsibilities and optimize your performance, and hopefully we're giving you the tools and the resources needed to find the right thing to fit your workload. So with that, I will open it up for questions for a few minutes. And again, this is a really high level. I can talk about Azure literally for days on end. So and just Azure SQL, I can talk about it for a whole day. So if you do have other specific questions that you think of tomorrow or next week or in a month, please contact me too.
Definitely is drinking from the fire hose a bit. So, but it was, yeah, a lot of information. Oh, that was great.
Good.
Yeah, I was always puzzled a little bit by the whole DTU concept. I'm like, this is not, doesn't seem very easy. So yeah, the newer model, the vCore, definitely seems to make more sense. And then, of course, like you said, the flexibility is the big benefit there. So that's cool.
Yep, I agree. And I kept running into those cases back in my consulting days before vCore became available, that we'd have, again, the small database that had a large amount of transactions, or the large database that had a small amount of transactions. And I was always like, well, this doesn't work very well. This is so much more expensive than it has to be. It's nice to have those two options separated.
Jess, this is Joe. So
Yeah.
I want to make a comment that is much more high level than just SQL Server database. But since you're on the Azure, you're involved in the Azure space, I'll bring it forward.
Sure.
One of the things that kind of is a little bit of a blocker for me to learn Azure the way I want to is that I don't use Azure through my day job. So if I'm going to use Azure, I have to use it personally, and I've run through all the emails I can think of that would give me the free year or whatever. So I'd like to see, I guess, what I would call like a training SKU for Azure costing, so that I know that I can go in as someone who's just learning, that I'm capped at some reasonable amount a month, $25, $50 a month. Maybe you can already do this and I just don't know how, so that I can learn and I'm not going to make that $3,000 mistake,
Yeah.
with my own credit card, right?
Yeah.
So I want a learning account capability.
Okay. I know there are some programs out there that exist. I haven't looked into them recently to know what's available and who you have to, like, where you have to sign up or anything. But if you can send me an email, I will be happy to look at that within the next week or so and tell you what's available. That's
Okay.
probably a really good thing for me to look up and put in this slide deck anyway.
Okay.
That would be a great bump, please.
Okay.
Yeah.
Yeah, if I could just get that building fear out of my head and actually be comfortable in the space, it'll be much better. I would become very unpopular with my wife if I made that mistake.
And you don't always want to go, oh, I just worked with it for 30 minutes. Let me delete everything that I just spent 30 minutes building and come back in another 30 minutes tomorrow and redo it all.
Ramp it all back up, right?
Yep. Let me check into what's currently available for you and pass that along.
I'm sure I'm not the only one that has that concern, right?
No, you're not.
And the equivalent thing is the developer edition of SQL Server, right? I could install that. I could play away to my heart's content and try every single feature I felt like, and it really was a great and still is a great learning tool. I want the equivalent in Azure, not only for SQL Server but for other services.
Yeah.
Yeah, I wouldn't mind hearing that feedback as well.
Yeah. Please send me an email so I can just do some research on where that stands right now.
Okay, will do.
Again, pricing has not been my forte for a few years, so I always need to research that stuff when people ask. But I will happily do that.
Cool.
All right.
Anybody else? Questions, comments?
thanks for taking time out of your evening. I know it's summertime. I know that we are all tired of virtual everything all the time. So I seriously appreciate it when a year and a half into this crazy virtual world, everyone still shows up and talks to me for a little bit. So I appreciate it.
Oh, thank you for sharing your time.
Yeah.
Absolutely. Been looking forward to this one, and glad we got it. And I think we're scheduled out through the end of the year for our speakers with Detroit, but probably in the next few months, probably getting fall, I'll start trying to schedule up 2022. Boy, that sounds weird. And so I might reach out again, and maybe you can talk some ARC.
Yeah, I was going to say when I'm about 6 months into the role, right, I'll have a better handle on it and start talking about it. So I would love to talk to your groups about, what is Azure Arc? Why would you want to use it? What's the hard parts of it? So yes, please do reach out, Michael.
Will do. Excellent. Thank you very much. And so I'm going to go ahead and stop the recording. Actually, from the time, it looks like from the time I started the meeting, it just recorded it. So like showing almost like 2 hours at this point. So I'll whittle it down and